Yes, ma'am. Recording na po ako.
Okay, okay.
Should I start na po?
Adrian, please introduce the panel and tell
Yes,
about rules.
Okay, so on lang po ng video. Okay, so good morning. Morning, Ma'am Soriano. Good morning, Gab. Morning, everyone.
Good morning.
Jemima. So today will be today here we are here to listen and to see Miss Jemima's thesis defense titled Impact Velocity Estimation of Ink Drop from Stain Patterns. So the whole presentation will be 30 minutes, and after that we will proceed with a 30-minute Q&A. So I'll be one of your panel members. My name is Adrian Baybay. The other one is Alkuino.
Hello.
And why not po ba yun, no?
That's
Sorry.
it. Yeah.
Okay, so let's start.
I'll start now. Once again, good morning, everyone. This thesis was performed under the guidance of Dr. Maricor N. Soriano. Now, a brief outline of what I will be discussing is shown here. I will first go through the background and discuss the current methods in bloodstain pattern analysis and how impact conditions can be obtained based on the stain and physical properties of the drop. And then I will discuss how I obtained the physical properties of the solution used, how I conducted the passive drop experiments, and how I processed my images. Afterwards, we will look at the relationship of the tilt and slant with the impact conditions, as well as the complete impact conditions obtained in these theses. And then I will summarize everything again in the conclusions and recommendations. The introduction. Bloodstain pattern analysis is a practice in forensic science and crime scene investigation that uses the size, shape, and distribution of blood stains to determine the activities and mechanisms that produce them. A drip stain is a blood stain resulting from a falling drop that formed due to gravity. Now, the current method in determining the origin of a drip stain is the string or the tangent method. This method assumes that blood drops travel in straight trajectories from the region of origin to the target surface. However, this method causes up to 50% error in the estimation of the height of the source. Now, multiple studies have been done that includes gravity to relate the drop size and the impact velocity to the final size and shape of a blood stains. But these studies usually use the spines or the scallops of the stain to get the impact conditions. Also, most studies usually focus on perpendicular impacts. In this study, I applied BPA on an ink water solution. Now, instead of using spines or scallops, I'm using the measured properties of the liquid and images of its stain to get impact conditions. I'm also introducing two angles, the tilt and the slant, instead of just a perpendicular impact. Now, using two angles inferred from a drip stain, an angled source, which is the cannula here, can be obtained using the string method. Now, the impact angle alpha is just the angle the drop makes with the surface before contact. It can be expressed by the arc sign of the width over the length of the produced stain. Now, the directional angle gamma is the angle the stain makes with a reference line on the surface, as shown here. The reference line is drawn parallel to the vertical grid of the surface. In back projecting the trajectory of an angled drip stain, the directional angle is first used to determine the projection of the origin on the surface, and then the impact angle is used to translate this projection to the point of origin in 3D space. Now, instead of a varying source, we can introduce a tilt and the slant on the surface and fix the origin instead, so that passive drops are created. Now, the combination of tilt and slant would create an elliptical stain where the alpha and the gamma angles can be extracted from. Now, the magnitude of impact velocity U can be expressed by the spread factor of the drop. and the properties of the liquid, such as density, viscosity, and surface tension, as shown here in equation 2. The spread factor beta shows how much the drop spreads upon impact, and it's given by the ratio of the width of the stain and the drop diameter. It is also dependent on the properties of the surface, which can be expressed by the constants A and B. Note that in this study, I used literatural values of a cardboard stock for A and B. Now, these literature values came from a previous study by Attinger et al. Now, the density, viscosity, and surface tension are something we're very familiar with. The density of the solution is just mass per unit volume, which can be measured directly. The viscosity can be measured by dropping a sphere in a column of the liquid and waiting for it to reach terminal velocity. Terminal velocity is achieved when the gravitational forces and the drag caused by the viscosity of the liquid are balanced. And then surface tension is given by a rearrangement of Duran's law. Now, this law states that the maximum height of a liquid in a capillary tube is inversely proportional to the radius of that tube. Now, the drop diameter d and the impact velocity given by its magnitude, the impact angle alpha, and the directional angle gamma express the complete impact conditions needed to reconstruct the trajectory of the drop that produced the stain. Once we have the complete impact conditions, it can be used in future studies to find the origin of the drop. Now, how did we obtain these impact conditions in the study? We will discuss this in the methodology. The use of pig's blood is highly discouraged in experiments since it can contain pathogens that can cause sickness. Now, human blood is recommended for BPA. However, its proper storage is difficult in experiments performed at home. For this reason, I used a cheap water-based ink bought online called Yasin UV dye ink, and I mixed this with water for my experiments. I chose magenta just to make it look similar to blood. Note, however, that I did not record the concentration of ink and water in my final solution, so I cannot repeat my experiments to get the same results. There may also be lots of errors in my measurements since I only used ordinary tools at home. But since the ink I use is water-based, and we will assume that it has properties close to that of water, and we can compare the results for both my ink solution and water. An important method also in this study is the use of a smartphone camera for measuring length and time. I documented all my experiments with a Xiaomi Redmi Note 7. I took photos at 48 megapixels, and my videos were captured at 60 frames per second at 1080 pixels. Now, moving on to the properties of the solution, how did I measure those? To measure density, we have to get the corresponding mass of a measured volume of the liquid. For this, I use an electronic kitchen scale with a least count of 1 gram. This device turns off automatically after not detecting any change in mass for 1 minute. So dispensing the liquid by drops was very challenging. Now, to circumvent this problem, I combined the use of a 5 ml or a 3 ml syringe with a 1 ml syringe. Now, the solution from the bigger syringe was dispensed rapidly so that the scale could detect the mass of the liquid. Then, I used the 1 ml syringe to dispense liquid slowly until the scale registers either 6 grams or 4 grams. Now, the volume left on the 1 ml syringe was then subtracted from the original combined volumes of the 2 syringes. Now, to measure viscosity, I used 2 marbles and I transferred my ink solution to a longer clear plastic container to make a falling sphere viscometer. Now, to get the radius of the marbles, I located the centroid of each marble, which is marked by the groove design here. I held this centroid against the ruler, and I took a photo and processed the image on MATLAB. Now, the length of 1 cm in pixels was measured and compared to the vertical and horizontal diameters in pixels of the marble using IMTool. I did this 3 times for each marble. I also weighed it on the same electronic kitchen scale as before and calculated the density of the marble based on those measurements. Now, to get the terminal velocity of the marble, its fall in the column of solution was videotaped. It was played in VLC Media Player with an extension called time to see the time in milliseconds of each frame. I looked for the moment the marble reaches the lines marked by these two arrows here. This was repeated 3 times for each marble, and the terminal velocity of each trial was calculated. Now, I chose the viscosity of the marble that yielded lower standard deviation from 3 trials for future calculations. And the final property is the surface tension. Now, to measure surface tension, you need the capillary height here. Now, to measure capillary height, I dipped a capillary tube in the solution while holding it next to a ruler and videotaped it. I played this again on VLC Media Player, and I measured the lower and the upper meniscus the moment the full edge of the ruler touches the surface of the solution. The angle theta was approximated through trigonometry from the inner radius of the capillary tube and the height difference of the lower and upper meniscus. Now, this experiment was performed 6 times, but 2 recordings were discarded because their videos were unfocused. Now, moving on. Now, to create the tilt and the slant, I created a box that could support a cardboard platform at different tilt and slant angle combinations. I propagated the slant angles of 15, 30, 45, and 60 degrees from this side of the box. And then I recreated those same slant angles on the other side of the box at different heights. I connected these 2 sides together, and the tilt angles were calculated using trigonometry from the height difference of the sides and the length of the supporting wall as shown here. Now, the platform itself, this one, is just illustration board covered with plastic cover. I would attach a sheet of graphing paper at the center of the platform where the stain can form. And after I created my platform, I placed my ink solution in a makeshift IV bag, and I allowed the solution to drip through a cannula placed above the box as shown here in figure 9. Now, the cannula is directly above the center of the platform at 45.5 centimeters from its highest corner. I allowed only 1 drop to stain the graphing paper at a specific tilt and slant angle combination. After each trial, the cannula was wiped dry with a tissue to make sure that the detached volume remains constant throughout all the experiments. Now, I recorded the release of a drop and the video frame showing the moment the pendant drop turns into a sphere was extracted. Now, using ImTool again, I measured the length in pixels of 3 square edges closest to the spherical drop. The ratio of the pixel length and the actual length of the square edge was used to calculate the actual drop diameter. Now, this was conducted 3 times, and the average of the drop diameters was used for future calculations. Now, I performed the passive drop experiments with the ink solution with measured properties and called the results there set 1. And I decided to repeat my experiments with a solution of a different concentration at a different initial height and called it set 2. I did this just so I can verify trends in the impact and directional angles, which I will be showing later in the results. Now, after that, after the drip stain experiments, I allowed the stains to dry and I took a photo of them. Now, these photos were cropped, skewed, and warped in Adobe Photoshop so that the grids of the graphing paper are oriented properly and only the parent body of the stains are included. I then fed the images into MATLAB and converted them to grayscale. And next, the global intensity of the stain and background was estimated from the histogram of all trials, and the background was subtracted to get the thresholded binary image. Now, I performed morphological operations using these structuring elements to clean the images. To remove the grid lines, morphological opening was done with a disk of radius 5 pixels. To reconnect the segments of the parent body, morphological closing was done with a disk structuring element of radius 15 pixels. Morphological opening is just erosion followed by a dilation, while closing is done in reverse order. Now, I filled the remaining holes in the image and filtered the image so that only the parent body gets extracted. Now, for visualization, I fitted an ellipse here in red. Now, after processing, I extracted the following features using region props. Now, these will be useful in understanding the relationship of the form stain with the impact conditions. An eccentricity of 0 means that the region is circular. Now, this usually forms at perpendicular impacts. Now, an eccentricity of 1 means that the region looks more like a line. The major axis length L is just the length of the parent body of the stain, while the minor axis length W is just the width of the parent body. The orientation describes the angle the major axis of the stain makes with a horizontal reference line. The gamma angle can be easily calculated from this using equation 8. Okay, now let's discuss the results obtained from these experiments. Now, we expect a drop to form a circular stain at a perpendicular impact, and we expect this to turn into an ellipse as the angle of impact is increased. We see in this figure that as expected, when the slant of the platform increases, the eccentricity of the parent body also goes to 1. Now, as the slant is increased, the volume of a drop is distributed downwards. Now, this results in a longer and a thinner stain as shown in this figure. Again, no conclusions can be made for the tilt. Now, based on equation 1, the impact angle and the length of the stain have an inverse relationship. Now, an inverse relationship is also therefore expected between the slant of the platform and the impact angle. This is proven in this figure where both the ink with known properties and unknown properties follow the inverse trend well. A linear relationship between the impact angle and tilt could not be established as well. Furthermore, it can be inferred from figure 1 that the slant is just 90 degrees minus the impact angle alpha. This is proven by plotting the two values against each other. We can see that the trend follows a diagonal line shifted with a bias. Now, a strong correlation between the directionality of the stains and the two angles of the platform could not be established as shown here. However, in earlier comparisons of the tilt against other values, such as eccentricity and impact angle, the goodness of fit are in the 0.019 to 0.027 range. Now, the goodness of fit for the tilt in this case is 1 order of magnitude greater than previous fits. So here we can say that a weak linear relationship between the tilt and the directional angle exists for small tilt angles. Now, the tilt angles used in this study only range from 6.2 degrees to 19.4 degrees. In comparison to the slant angles used, the difference between these values is too small and cannot represent larger angles. This is the most likely reason for the tilt not having a noticeable effect on the eccentricity, width of the stain, impact angle, nor directional angle. Now that the directional and impact angles have been obtained from the images of the stain, we can proceed to obtaining the other impact conditions, such as drop diameter and impact speed. From 9-pixel measurements of square edges and drop diameters across 3 different trials, I obtained a resolution of 1.9 millimeters per 7 pixels. This results in a drop diameter of 2.3 millimeters. To reiterate, we need the properties of the solution to get the impact speed. Now, the average density of the ink solution was determined to be 1.05 grams per ml. Now, this is 5.53% away from the density of water at 32 degrees Celsius. Now, all trials were measured to be within negative 1.57 and 1.21 standard scores from the mean. The minimal standard scores and the small deviation from water of the ink solution means that the obtained density of the solution is acceptable. Now, the standard deviation of viscosity values calculated using the first marble is lower than that of the second marble. Hence, the average viscosity obtained from the first set of results was used for future calculations. However, we can see that the obtained viscosity of 306 millipascal second is 3 orders of magnitude away from the viscosity of water at 32 degrees Celsius. Now, to see where this huge error came from, I plotted the position of the marbles in the column of water against time, and I discovered that both marbles show an almost linear motion. Now, for a sphere falling in a column of liquid, we expect half of a parabola as it increases velocity and a line with constant slope when it reaches terminal velocity. The plots here both show that both marbles have only started to pick up speed and haven't reached terminal velocity when they reach the end of the column of the solution. Other sources of errors could be the orientation of the camera, which may have caused errors in reading positions, as well as the slower frame rate of the camera compared to the falling marble. Now, if the marble reached terminal velocity, V would increase, and the viscosity of the solution is expected to go much lower, closer to the viscosity of water. Now, the average surface tension obtained through 4 capillary rise experiments was 0.0516 newtons per meter. This is 26.76% away from the surface tension of water at 33 degrees Celsius. Now, this large deviation may be attributed to the very small difference between the heights of the lower and upper meniscus in the extremely narrow tube. Now, the capillary tube was also not ensured to be parallel to the camera when it was dipped in the solution, which may have caused errors when reading the heights of the meniscus. Now, to summarize the physical properties, we can see that at similar temperatures, there is great deviation obtained for viscosity and surface tension to that of water. Now, I plugged in these values to the formula above here to compare the resulting impact speeds. Now, the figure here shows the relationship between the impact speed and the width of the stain using the obtained properties of the solution, as well as the properties of water. Now, for the same liquid and same drop diameters, the equation for impact speed becomes dependent on just the width of the stain. So for B equals 0.235, a quadratic relationship can be seen between the width of the stain and the impact speed. Now, both liquids follow this expected trend. However, we can see that the results of the solution varies greatly with that of water. We can also see in the next slide that there is a great difference between the obtained values with that of water, even if both follow the expected inverse relationship. This is because of the very large deviation of the obtained physical properties of the solution to that of water. Now, the impact speeds for both ink solution and water at different tilt and slant angle combinations were tabulated here. We will note here the slowest and the fastest impact speeds for the ink solution. Now, the slowest speed of 12.88 meters per second is around 46 kilometers per hour. This is already twice the recommended speed for cars inside the UP Diliman campus. And the fastest speed obtained for the ink solution is around 250 kilometers per hour. This is also around twice the average speed of a baseball pitched by a professional baseball player. Now, these two values seem impossible for a small ink drop falling from a height of less than half a meter. This is due to the large errors obtained from the measured properties of the ink solution. Using the kinematic equation for final velocity and the known distance of the cannula from the platform, the impact speeds are expected to be around 2.99 meters per second. Now, averaging the impact speeds for water, I got 2.52 meters per second. Now, the deviation from the two values is most likely due to the constants A and B borrowed from literature. Remember that stain formation is also dependent on the properties of the surface. I assumed that the graphing paper backed by plastic cover in this illustration board used in my study would have similar constants to the cardboard stock used in a previous study. However, we can see that these two surfaces may not have the same absorption properties as I previously thought of. Now, to summarize, in this study, I was able to establish the linear relationship between the slant and the eccentricity of the stain, as well as the inverse relationship between the slant and the impact angles and the width of the stain. The complete impact conditions were also obtained for different tilt and slant angle combinations for both the ink solution and water. Now, the impact speeds of water are closer to the expected because of the large deviations in the measured properties of the ink solution. For recommendations, first, I recommend the use of a broader range of tilt angles so that its effect on impact conditions can be better understood. Second, I recommend the use of an ink with known properties and to note the concentration of solutions used for future ink drop experiments. Third, in measuring viscosity, a longer cylinder would provide a longer path for the falling sphere to reach terminal velocity before stopping. Fourth, in measuring surface tension, ensuring that the capillary tube is parallel to the camera will help make more accurate readings. Finally, the use of a surface with known A and B constants will make more accurate impact speed measurements. This thesis would not be possible without the support of DOST-SEI throughout my college education, my parents who raised me to love science, and my brother for helping me buy a laptop in the last minute so I can finish this thesis. Alena for being my emotional support during the whole pandemic and thesis period, and all my other family, friends, and classmates. Thank you for all your help. That's the end of my presentation. Do you have any questions?
Okay. Thank you for the talk. It's very good. Yung audience ba, let's go first to the audience. Let's ask first the audience kung may questions sila regarding the presentation. Wala naman ba? Ikaw, Gab, do you have any questions?
Okay, meron. Pero hintayin muna natin yung, wala na bang question sa audience? Baka nagka-type pa eh.
Okay. Sorry pala doon sa medyo padulo na-disconnect ako. Sorry. Faulty ang internet.
Okay, so examiners. Okay, so sige. Tayo mo. Gusto mo ba mauna, Adrian?
Ikaw muna.
Sige, so pwedeng pa tingin uli nung yung the table nung slide 40.
14 po.
40. 40.
40. Wait. Here po.
Ayan. So bakit yung tilt at yung slant, bakit yan yung choice mo? So bakit yung 15, 30, 45, ganun?
I originally chose 15, 30, 45, and 60 for both. Just so it's more representative of mas broader yung range ng angles, tas mas representative siya ng almost all parang like mas representative siya ng lahat ng pwedeng mangyari. However, upon measurement, I made the length of my platform longer. That's why the tilt angles became very small. So, yun po.
So, nakaka-affect ba yan dun sa mga data? Wait lang, hanapin ko ng slide number. Yung mga plots, since yung, kunyari, yung sa, ano ba yun?
Yes
sa
po.
width angle. So, medyo mas mataas yung R-squared nung slant, no?
Opo. It's because mas maliit po yung the difference in the tilt angles used was too small. Kaya medyo hindi makita yung trend.
Okay.
Compared here po kasi sobrang laki ng difference nila. Kaya mas obvious po siya.
So ano pala yung sobrang noob question. Ano yung difference nung yung tilt at slant sa
Yes,
setup. So, bawal ba silang pagpalitin? Or ano yung nangyayari?
So yung tilt and slant po, ano lang siya, I arbitrarily chose this axis for the tilt, and then I just chose this axis for slant po. So I think for future studies, you can interchange them naman, pero you have to note that it's different. So the slant would affect the impact angle as shown here po, na they are complementary. However, for the tilt angles, I was not able to establish yung relationship niya with the gamma angle because I used very small tilt angles. Yun nga po.
Okay, so, sige, thank you. So, si Adrian muna.
Okay.
Mag-iisip pa ako ng tanong.
Okay, so before yung mga questions ko, may curious lang ako, yung experiment mo ba ginawa mo at home yan, yung setup mo? Oh,
Lahat po. Apo.
cool. Magaling.
Thank you.
Just a comment about that. All the supplies that they needed, they bought from, the usual channels, Lazada, Shopee. And inspired by Isaac Newton during a pandemic, they did experiments at home.
Opo.
Galing. Kasi in-imagine ko kung ako yung gagawa, parang
Opo, nakakaiyak po siya minsan.
mahirap. Okay, ano ba yung mga question ko? Ay, baka mali lang yung understanding ko. Yung impact velocity is yung velocity nung droplet ba? Tama ba yun?
Opo. When it
Pag
moment
hit niya
it touches
yeah.
the surface po.
So
Sorry. Yeah.
so paano mo pala dinefine or paano mo sinolve yung impact velocity again? Baka hindi ko lang nakuha. Kasi 'di ba ang pagkakaintindi ko is because it's just a drop. So yung force na nag-act lang is gravity. Tama ba yun? Or
Yes po.
so paano siya may other ways pa ba para mag-vary yung impact velocity niya or something? Baka
Yes po. Yung the thing is, yung impact velocity for liquids, it varies because of the surface tension, the viscosity and the density of the liquid. So affected po dito yung drop formation, tapos yung pag-form ng stain. So from a previous study by Adrian et al., they established na this relationship between the properties of the liquid and the impact speed or the magnitude of the impact velocity. So that's why
wait lang. And yung D, pero yung D, di ba,
yes po, the drop diameter.
define siya with V, tama ba yung sa next page? Or baka hindi ko lang na-pick up agad. Di ba
Ito
yung
po ba?
may binigay kang D na defined using velocity ba yan? Ano yung slide? Sorry, hindi ko nakuha yung slide na define mo yung big letter D. Sige.
It's the impact conditions.
The impact conditions.
Kasama yung D.
Wait lang po
Yeah, sorry.
So yan po. So the impact conditions, you need this.
Sorry. Okay, tama pala. Sorry.
Yeah, you need this po para po siya sa reconstruction na ng trajectory ng stain.
Mm-hmm. Okay. And so yung ginamit mo na substitute na blood, may gano'n pala siya ka-close sa human blood? Or may ganun ka bang may ginawa ka bang ganung connection na yung results mo is because results mo ganito maybe dahil hindi siya as close as to a human blood na specimen or something?
Hindi ko po siya na-define, pero I mentioned sa manuscript ko yung properties ng blood. Hindi naman po ganun kalaki yung difference. Pero yun, dahil nga po, di ba yung blood, it has plasma, it has solid property. So magkaiba talaga yung viscosity and yung mga properties na yun. So what I did here lang is I compared it with water kasi mas expected ko na close siya sa water. Pero for all these liquids, yung mahalaga naman po is we know the properties kasi all these impact conditions, galing lang siya sa properties and the stain lang po. So even if you use blood, even if you use other liquids, theoretically, dapat makuha mo yung impact conditions po.
And trinay mo na ba siyang kasi di ba kanina may ginawa kang comparison dun sa usual na ginagawa sa forensics, which is yung straight line lang? Tama ba yun?
Po, yung tangent method.
Yeah. And may ginawa ka bang, or baka yun ba yung future mong gawin? Yung results pa ba may parang reference results ka ba na kinompare, tapos may nakita ka bang like improvement dun sa results na yun using your method?
Okay, comment lang ako.
Sige.
May master student ako, si Wilbur Galarion, na yun yung ginawa niya, actual blood, but pig's blood, because pig's blood, the viscosity, density, and surface tension of pig's blood is very close to human blood. So, nung pre-pandemic, nagawa niya itong experiment na to. Using actual blood, pig's blood.
Yung sagot ko po dun sa tanong ni Sir, meron po akong literature, a previous study po before, hindi ko po siya na-cite sa slides, pero nasa manuscript po siya, na tinry po nila yung string method, tangent method, without the gravity. Tapos nakita nila, it can reach up to 50% error sa height. So imagine if wala kang witness, tapos meron ka lang blood stains. Tapos yun lang yung magagamit mo to reconstruct the crime scene. Kung 50% yon, so pwede mong masabi na either nakatayo siya or nakaupo yung victim. So malaki na agad yung difference niya. So especially in the context ng Philippines, lalo pag sinabi nilang umupo, nakaluhod, or nakatayo. So it's a big deal already po. So,
okay. Gab, may other questions ka pa?
Wala muna. So, yung audience siguro muna.
Wait lang, meron pa ako dito. Doon pala sa sorry, kung may questions ba? Kung wala pa, may tanong muna ulit ako. Doon ulit sa slide 18, baka hindi ko lang na-pick up din yung explanation mo. Bakit ulit hindi kasama yung tail part ng drop, but hindi siya kasama sa...
Ay, yun po. Sorry, hindi ko nasabi. It causes error na po sa estimation ng impact angle. Kasi di po ba, the impact angle is dependent on the width and the length of the stain. So a previous study mentioned na they tried doing this with the stain, including the tail. This is the tail po. They tried this, including the tail and the parent body. Tapos mas malaki po yung error nung kasama yung tail. So if you also imagine, kasi po yung tail, na siya, kumbaga secondary na siya na impact. So ito yung gaganon na siya. So medyo may error na po siya dun.
Okay. Parang kasi, na-imagine ko kasi na parang hirap din siguro i-determine kung alin yung parent na, ano yung pinaka-initial drop. Kasi kung sa context ng crime scene, hindi ba parang sobrang scattered all over na yung droplets? So may way ba para malaman natin kung alin yung mas pinaka-major na drop? Or ang ginagawa ba usually dyan is just i-measure na lang lahat tapos tingnan na lang yung mga relative errors nila?
Usually, ang ginagawa po kasi is you have multiple stains po sa isang surface. So what they do is they take a picture, tapos gagawin lang sila ng threshold. So meron silang i-reference na size ng stain. Tapos tignan nila yung mga anything smaller than that, tanggal. Tapos lilinisan using morphological operations para matanggal po yung mga so kunwari nilinisan mo, pag nilinisan mo siya, tapos yung disc mo ay mas malaki, dito. So mawawala po yan. Tapos mawawala yung connections. Mawawala yung connection nila. Kaso kunwari mas maliit to dun sa reference mo ba, mawawala siya. So ganun po yung ginagawa nila usually po.
Okay.
Imang, how do they determine kung saan galing yung blood splatter? Did they only use one splatter?
Usually po sa experiments nila is gagamit sila ng
Sa forensic practice, how do
Yes,
they
ma'am.
trace back ang source ng blood? Do they only use one splatter?
No, ma'am. They use multiple po at different distances po from the surface.
No, there's only one. No, back to the crime scene. May isang crime scene. Yung dingding, maraming splatter. Kukuha lang ba sila ng isang splatter dyan to determine kung saan galing yung dugo?
Hindi po, ma'am. What they do is hahanapin muna nila yung mukhang interesting na pattern. Tapos they'll take multiple pictures. Tapos syempre using all those pictures, they would pagsasama-samahin nila para mahanap nila yung mismong source po.
So what's the purpose of getting the impact velocity? Why is it important to determine the impact velocity of multiple stains?
So if you get the impact velocity of yung multiple stains for a single event po, no?
Yes.
Ma'am, so if you get the impact velocity po, you'll get a more accurate trajectory. And then those multiple stains, pag pinagdugtong mo yung trajectories nila, yung region of origin mo would be yung intersection nung trajectories. So if you use the impact velocity, mas liliit po yung region of origin. So mas maliliit yung error. So kung saan, mas mapipinpoint mo kung saan talaga siya nanggaling.
So for example, meron kang dingding, may mga splatter dyan, and each of these splatter point to different impact velocities. But when you trace back
Yes,
ala
ma'am.
projectile motion, kunyari ito na yung impact velocity, initial velocity mo, babaliktarin mo lang yung direction kasi nung umpisa gumanon siya, ngayon babaliktarin mo lang pag ganon siya.
Yes, ma'am.
All of these parabola would likely intersect from where the
Yes, ma'am.
origin of the blood would be. Tama?
Yes, ma'am. Yes, ma'am. Yes, ma'am. So,
So, yun-
tapos, ano
would
po,
be-
if mas accurate po yung impact velocity mo, mas liliit yung region of origin mo. Yan po. Mas liliit yung possible source po.
Cool nun. Sorry.
Di ba? Ang cool. Opo.
So by that, wait lang, sorry. So baka sobrang hypothetical yung question ko. So by that, following that, kaya mo bang i-predict kung ano yung naging source or naging cause nung spill na yun?
Well, yung cause po, like yung the action, like gunshot or sinaksak, parang ganun.
Yeah. Kaya ba? Or sobrang hypothetical ba?
That's what they do po. Kasi yung stain patterns ng gunshot magkaiba sa kunwari sa sinaksak or may tumalsik na dugo. So kapag gunshot, you expect maliliit, sobrang liliit ng droplets.
Yeah.
Tapos meron kang forward, tapos may backward na stain. So meron kang stain dito, tapos may stain ka dyan. Ngayon, sorry.
Sorry,
kapag sinaksak naman, medyo mas malalaki yung stains. Parang ganito siya. Kasi it's an impact pattern na. So, mas malalaki, tapos medyo kalat-kalat din. Tapos kapag meron ka namang cast off, yung may na ganun lang, isang line, parang medyo line sila. Parang, hindi naman siya line, pero parang makikita mo yung motion ng object using that. Ganun po.
Is it something na parang ano siya? Is it something na may template na, then using your analysis, pwede mo i-run backwards, tapos i-check mo doon sa template para malaman kung anong class, kung ano na yung naging source niya?
Currently, yun po yung ini-establish ngayon kasi hindi pa siya, itong field na to, kailangan pa siyang kumbaga, mas i-establish. So that's why they're doing this. Ngayon po, ang program pa lang ay yung hemospat, tas backtrack. Tas usually, ang gamit lang nila is yung string method lang. So tangent pa lang. Kaya that's why yung mga current studies ngayon is tinatry nilang i-improve yun. Tapos yung para malaman po yung if ano talaga yung cause, like for example gunshot or sinaksak, wala pa pong ganun. So ngayon you just have to look talaga sa diameter, like individually ng analyst na mismo.
Okay.
Pero pero meron na pong na-establish na ano, na parang dataset. Ganito usually yung ano niya. Pero wala pang program for it.
Parang cool lang kasi na.
Future.
Yun yan. Sige pa. Tingin pa ako ng questions ito. Ikaw, Gab, may
Oh, may
naisip ka na?
pwedeng magtanong. Sige.
Sige lang.
Sige. Yung sa pag-measure ng viscosity ng fluid, so bakit marble yung ginamit mo at hindi, for example, coin? Ganun.
Kasi po,
Hypothetical lang.
so po, kasi pag, kunwari, we need it to be sphere para laminar flow. So, para straight lang siya. Kasi pag, kunwari, coin, then, magkakaroon ka ng turbulent flow dun sa likod, tapos medyo mas, hindi na siya maganda. Yun po. May mas malaking error dun sa results. So, tas marble po, kasi, yun lang po yung nahanap ko sa bahay.
Okay.
Gusto ko sana yung LED balls po, pero wala eh.
Yung pwede punta ka sa next slide dyan, sa 14. Ay, may tanong ka pa ba, Gab?
Hindi, una ka na.
Sige. Paano, na-imagine ko kasi parang sobrang hirap nito gawin yung pag-measure ng, kawan ko, kasi kung ako ini-isip ko parang sobrang madali akong magano. May in-account mo ba yung parang maging, or gaano ba ka-important talaga yung pagkuha niyang surface tension mo? Kasi parang pwede siyang pagkuhanan ng source of errors, tama ba? Kasi kung ako siguro gagawa na sobrang nanginig yung kamay ko pag nag-measure.
Yes po. So yung surface tension, it affects talaga po yung impact speed. So ano siya, because it's ano mo siya in the raised to 1/4 siya eh. So malaki siya. Ngayon, yun. So mahirap siyang i-measure, pero for work from home setup, I tried bumili ng capillary tubes. That's what I did para tinry ko lang na i-minimize yung error was to do this multiple times. Tapos binidyo ko po sila bawat isa. Kasi di ba, kunwari i-read mo siya mag-isa, then nagkamali ka, naduling ka, wala na. So ginawa ko, binidyo ko po bawat isa. Tapos frame by frame, pinlay ko sa VLC Media Player. Tapos hinanap po yung moment na as in talagang gaganon na siya. As in, didikit na po yung ruler sa surface. Tapos medyo mag-i-start ng mag-adhere yung liquid. So, yun. Tapos, ang ano naman kasi is almost, similar naman po kasi talaga yung difference ng lower meniscus tas upper meniscus all the time. Similar dapat po. So, yan.
Na-curious lang kasi na-imagine ko to parang yun natin yung sobrang hirap na part ng pag-measure kasi and sobrang pwede siya maging possible sources of errors din. So,
actually, ito po yung pinakamadali. Yung pinakamahirap po. Yung pinakamahirap ko, ito po itong density. Kasi yung weighing scale ko, tinatry kong mag-drop slowly, tapos bigla siyang namamatay. Tapos, na-stress ako. So, kailangan ko po siyang gawin na may mabilis, na malalaglag. Tapos, yung 1 ml ko na lang, siya na lang yung by drops ko na slowly. Yun po.
Kasi ano yung limitation ng ano yun?
Opo, yung limitation ng nung weighing scale.
Pero cool pa din nung nagawa mo.
Thank you po.
Tanong ko na ba lang? Ikaw, Gab, may naputol ka kanina. Gab?
Wala na si sir.
Na-busy ata.
Hello. Naano ko kanina, nalaglag. Sige, yung last na question ko na siguro. Ano uli yung A and B na parameters?
Ayan po. Yung A and B, wait po. Here, yes. Yung A and B, I use 0.257 and 0.235. Obtain po siya.
Or ano siya?
For cardboard stock po. Yun po yung ginamit nila sa previous study here. So parang ano siya, constant na finite nila dun sa different na experiments nila before sa dito.
Counted na din yung, di ba may parang nilagay kang graphing Graphing paper ba yun?
Opo.
Or anong ginagawa ng graphing paper?
Para po, ano lang po siya, graphing
Graphing
paper
paper
lang
ba
po
tawag
para po makuha ko po yung mga position po. Para mas madaling
So,
mag-record po ng
hindi
position.
niya na-affect yung... Hindi niya ba naapektuhan yung A and B?
Yun po, affected siya, but yung inassume ko po kasi is dahil illustration board, tapos kinover ko ng plastic, tapos papel yung nasa ibabaw, I assumed na similar lang sila ng cardboard stock. Pero turns out, hindi po pala. Ayun, meron siyang difference. So yun, sa recommendations ko po ay sa future, gamit sila nung known na po yung A and B. Or if kaya nila, then they measure A and B first.
Okay.
Okay, thank you.
Thank you.
So, sa audience na siguro.
Sige. Yung audience ba? Last. Sige, Ma'am Ritz. Ma'am Ritz, go.
Hi! Hi, Imang. Great presentation. Congrats in advance. See you. And
Thank you.
Ling. Yes. Short question lang. Actually, one question lang. What if you have a scenario wherein yung stains or most of the stains are overlapping? May ma-infer ka pa ba from that scene? And can you still make use of the stains, of the overlapping stains? Like, pwede ka bang mag-perform ng morphological operations to isolate them? Yung mga ganun.
So what they usually do po is ina-avoid nila yung you mean overlapping yung
Yes, kasi
stains or nagmi-mix parang nagmi-mix na sila to make a bigger pool. Or nag-overlap lang po in general.
Yeah, overlapping lang, like at some angle, at some distance from the wall, ganyan. Yung mga stains na nabuo, overlapping sila mostly. So,
Yes,
ano yung
po.
ma-infer mo from that scenario? Or can you still make use of those stains? Yung processes na pinakita mo dito, gagana pa ba?
Yes po, definitely. Yun po yung purpose. Kasi pag pag overlapping na sila, if sa future you can run it in the program, makikita mo yung trajectories nung mga overlapping na stains. Tapos makikita mo, they would reconstruct sa dalawang regions of origin. So mas makikita mo, mukhang hindi siya isa lang, mukhang madami talaga siya. Yun po.
So, could you also mean, for example, 2 drops overlap at the same spot, and therefore you have 2 ellipses overlapping? Is that a scenario, Ritz?
Yes, ma'am. Yes, ma'am. Parang ganun. Kasi dun sa previous slide niya, nung nandun pa tayo sa impact velocity na slide, yung image processing part. What if dalawang ellipse yun? Ayan, yung parang ganyan.
Yung as in,
dalawa.
Sorry. Yung as in magkadikit talaga po.
Yeah.
Yun po yung thing is, ina-avoid po nila yung mga ganon. So, usually, you would have multiple stains. Tapos, you just choose yung stains na yung ganito lang po talaga. Tapos, gagamit ka nga po ng threshold na parang ito yung size niya. Na ito po. Pero if you have multiple stains, tas meron ka namang malaki, tas naman po, madami sila, then offset naman na yun ng madami. Hindi naman ma-offset, pero makikita mo naman po.
Ano ba yung limit? Like, ilang stains yung kailangan mo na isolated, na parang ganyan, para makakuha ka ng accurate na data, say, from a particular scenario?
It depends. Pag malinis po, kunwari malinis, tas yan lang, then, yung may nakita pa ako na they use around 25 to 40 na stains to reconstruct po. Pero syempre it's in a very controlled environment eh. So siguro if talagang nasa crime scene ka, then you would need as much data as possible.
Yes.
But hey, an overlapping stain scenario could be a topic for a new thesis.
Yes. Actually, kasi wala mo iba siya, diba? Hindi siya gunshot or hindi anything or may particular position na magproduce ng overlapping stains rather than isolated. Mga ganun. Anyway, and yun lang. Okay. Good job.
Okay, thank you.
Let's do a time check because we still need to deliberate.
May 5 minutes remaining pa po, ma'am. 5 minutes remaining. So if there are no more questions, let's move to deliberation.
Okay. So we thank Imang for the presentation, and we request everybody else to please leave the meeting as we go on private deliberation. Thank you very much all
Ako
for
din po,
being
ma'am.
guests. Oo. Co-host naman ako. Make me a host para hindi mamatay yung ano.
Ma'am, co-host po kayo.
Pag umalis ka ba, hindi naman mawawala. No?
Dapat
Co-host
po.
ako, no? Sige. So,
I'll
if we
stop my
may
share.
request, we may request everybody to... Ay, nga pala, bago umalis, picture nga pala. I almost forgot. Oh my God.
gosh. Oh my
Okay,
gosh.
so sorry. May mga umalis na ba? Una muna, picture with the panel.
With
Ano
the-
ba to?
Ma'am, kasi kailangan daw po yung title.
Oo,
No.
yan. Okay lang. So, is this
Ma'am, kayo
okay?
na po. Kayo na po, ma'am.
Sige. Side by side standard. Wait, ba? No, single. Wait lang. Side by side gallery. How do I remove the rest para yung ano lang, panel lang? Is there a way? Hindi ko alam eh. Anyway, sige. Okay lang. Sige. Screen. Okay. Smile panel. Screen. Got it.
Okay.
Okay. And for posterity, yung yung guests. Dali ha. Dali ha. Okay. How about the guests? So, Imang, please stop sharing para makunan natin ng picture din yung mga guests. Oh, ito pala. Wait, mas maganda. Thank you for doing this. Sandali. Print screen ulit. Mas malaki yung images ng panel mo. Wait lang. Ha? Okay, look at the webcam. Okay, thank you. Got it. Thank you very much, panel. Okay. Okay, and then, wait lang. Okay. And then, please stop sharing and then let's take pictures together with your... Ay, wala na.
Walis na po.
Malis na sila.
I'm sorry. Nag-alisa na sila. Okay lang.
Ma'am.
Sige. Sorry O sige. Imang, you may need to step out kasi mag-deliberate kami. And please stop the recording.